long, but there was one forever card that we didn't really hit very hard, and that's the reason why, plus it's track all day, I'm not spot checking right now. I'll spot check tomorrow. But we're not going to stick around in 6566 all day. We're going into 67 today as well. Okay? And we did our WCC, which some of you, the more going over, the better, kind of. At least with your mistakes. So we have one more big idea. But first, before our last big idea of section 6566, which has a bit of homework, right? A bit of homework in 6566. So if you haven't started it yet, you're gonna have your work cut out for you tonight. But is it as nasty as 6164 6587?
Nah.
I don't think so. Does it still use the handout?
Yeah.
Yes. So if you don't have that handout still, I told you to save it. You can come beg me for another one after school. I'll be here till 4. There is some handout work, there is some book work. I don't think it's crazy, but there are a couple weird applications that actually get us into section 6-7 that we'll look at for homework help at the end of the notes. What's it asking you to do? Find the derivative. Oh no. It's okay though, it's good. Find the derivative. Find the derivative of woohoo or what? Nope. The integral. Derivative, integral. Wait, an integral gets us an antiderivative. A derivative of an antiderivative, doesn't that kind of sound like it cancels each other out? A little bit? Don't we have a whole FTC Part 2 theorem thing that we looked at on Friday that's supposed to help us with this? Hey. So, if I'm trying to solve for, they could actually tell me use Part 2 of the FTC, or they could just say find the derivative and you should know what to do. Question. Does this fit the whole a to x of f of x dx, or f of t dt, doesn't really matter too much, formula the FTC Part 2 gives us? Does it fit?
Yeah.
Is there a constant?
Yeah.
Do I care what it is?
No.
Is there an x?
Yeah.
Mm-hmm. So if I did go to all the work of actually figuring out what that is, which, could you do that? Some of you could, most of you couldn't. We haven't learned how yet. If we could find the antiderivative of him, I would say, yay, there he is, and then I would say, oh, derivative. And when I take the derivative, that's how it works. At the end of the day, what's the result? Derivative of antiderivative is integrand. Derivative of a constant is 0. Now, if you don't like, which some of you don't, you'd rather it look exactly like, okay. So what do I do? Cosine of 2. It comes back to the original. X, not t. Why? Because he gets plugged in. That's not the solving procedure, but that's the trick to the rule. That's the trick to the rule. Now, I'm actually not going to have you guys do B, even though I'm sure you could. I'm just going to delete him. Hold on. Is he attached? No. Good. Let me give you another example. It's a different number. I don't know. It's a number that I just made up in my head. So, other one. There you go. Number next one. And literally, I don't know. What if I was to give you the following? What if I was to give you, directions are still the same, find f prime of x, but now you have that just got fun. Jimmy.
In the first one, how come it's not 2 goes correct?
Good question. Because I'm not looking here for my u prime. I'm looking here. So then I plug in x to where the variable already is. And it'd be times, if I'm taking the derivative of the it'd be times x prime. So I'm not looking at the actual argument. Good question, bud. I know, I made it super exciting. Is it legal? Am I able to just outright use FTC Part 2 right now? Go.
No.
No, what's wrong?
The X is on the bottom.
X is on the bottom, and where's he supposed to be if I'm technically following my...
Not on the bottom.
Not on the bottom. On the top, right? Wait, is there a property somewhere that lets me switch around bounds? Parsa, what is it?
I don't know.
Josh, you heard him. What do I do?
Put the 3x squared on top, the 17 on the bottom, the negative.
If I want to switch the bounds, I just have to make it negative. Is it now legal?
Yeah.
Yes, but it's way more exciting than the last one. How do I use my rule? Without having to anti-derive, which I promise you, you would not be able to do.
Really?
I don't even know if Calc 3 could do it.
Okay.
That's not
So we can't do
at the school. Could they? I'm gonna have to go to that huge old book of like integration formulas to do this one. Negative, good, because there has to be a negative. 6x. Keep going, you got it. Careful.
Wait, how? Where'd you get the 6x?
Ooh, good question.
Yeah.
What's FTC Part 2 say? If I'm doing the integral from any constant to any thing with the x's of f of t dt, guys, what's the formula say?
Oh, it's
F of u times u prime. Who's u again? Ooh, so I plug in u, and then u prime. Why is there a negative? Because I had to flip the bounds. Let me try to zoom in a little bit and scroll down just so we can make sure. I know I gave you a really hard one just to make sure. If you were to simplify, which we're amazing, we do that, right?
No, just response.
Thanks, Nick. I would have 1 plus 3 cubed is
I don't know.
27, 27 and 3, 81. 1 plus, someone double check me, 81, x to the multiply, raise the power to a power you multiply, right? If you go square root in that, you're killing a poor little innocent puppy, so don't do that. Stop, you're done. Make sense? Give me a thumbs up. 5 of you. Thank you. The rest of you? Questions? Man, come on, guys. Communication is key.
Wait, Miss, do you have a question?
Yeah,
The first one?
on the first one.
Yeah.
Can I scroll up?
Where did it, you didn't have the U prime for the first one? The whole thing about U prime?
What was the U in this one, bud?
2, or all is X.
So could I do times x
Okay.
prime?
Got it.
Totally.
Okay.
Diane.
Why is fx the entire? Why is sub f?
Why is this there? Because derivative of antiderivative, f of x, derivative of, if I plug in a number, it's a number. Derivative of a number is 0. And that's, remember, go back, study again. That's what we talked about on this page, because it's the rule, how the rule works. Now here's the step-by-step, okay? All right, kiddos, last big idea. Here we go, MVT for integrals. It is not that much different than, I promise, it is not that much different than MVT for derivatives. Actually, I should probably change that. It's not different at all, but notation is. It's not different at all. No, not in its foundation, fundamental principle. I don't know. I'm just throwing out words now. At its core, it is the exact same. But now that we have learned integrals, we can write it differently and use it differently. MVT for integration. At its core, it is the exact same as the MVT that we learned a long time ago. But in application, now that we've learned integration, kinda, we know the idea, hopefully. We can write it differently and we can use it a little bit differently. We can write it differently, we can use it a little differently. As you guys are setting it up for our forever card, which I think it's going to be forever number 38. Yeah?
Yeah.
Oh, it's a Monday, huh?
30.
Yeah,
38.
thank you. MVT, which we saw with FTC. Oh my goodness, so many letters to keep track of. Mean value theorem, average equals instantaneous. The average rate of capital F, which would be
B minus
the change in capital F over the change in like X. MVT, instantaneous equals average, or average equals instantaneous at a specific point. Why am I writing capital F's?
Antiderivative.
Because now, what am I being given theoretically, possibly? The rate, or the derivative, or the velocity. Ooh. The traffic flow. Ooh. Wait, that's somewhere. I'm being given a rate, possibly, and I need to think about it as, wait a minute, I'm already given the rate, so if mean value theorem, I'm actually going back to the antiderivative. How could I change this up? Well, kiddos, hold on. What is capital F prime? Yeah. Capital F prime is like what would be in the integral that I would solve to get capital F, otherwise known as little f, right? Hold on. What is capital F of B minus capital F of A? That just solves, right? Isn't that FTC? Antiderivative of B minus antiderivative of F. All I'm doing is changing the notation, but it's the exact same thing. I'm just looking maybe now at derivatives, and I'm having to think backwards instead of looking at a function and looking forwards to the rate. So, two different ways of writing it. I could write it little f of c, which is like the derivative of the ambiguous antiderivative, whoever he is. I shouldn't say ambiguous. Of the antiderivative. The derivative, but it's going to be little f, can be equal to the integral from a to b of f of x dx. However, I'm going to, hold on, over b minus a. Or, another way of writing it, f of c times b minus a is equal to the integral from a to b. The old mean value theorem told me in a certain interval, as long as a function is continuous, there's a special x where the tangent line at that special x was equal to the average. But now with integration, I'm saying there's a special x such that the height times the base, there's a perfect rectangle that equals the actual area. That's the graphical way of seeing it. Guys, you don't have to put this in your forever card. This is literally the old mean value theorem, but with capital F instead, and then us applying it to what we know now from integration. Have we already figured this out? Whenever we say C, the book could say X star. Our book says X star, other books say C, I don't know. Just a special one. How could I then apply this formula when they tell me outright, hey, use it? Use what? Well, I don't know, use the formula. Well, how? They give me a function. I get to think of him as a rate. I know integrals now, he doesn't have to be like a position, he can be a velocity instead. MVT for integrals, I'm just going to plug in. So instead of f of c in this example, I'm going to say square root of c. Instead of b minus a, I'm going to put this example's b minus a. Hold on, pause. Can you see me plug it in? F of c, f of c times b minus a. Here's a special height. Here's the overall base. Has to equal. What part of this do I still have to do to be able to solve? Yeah, integrate that thing, right? Because square root of x is the same thing as x to the... And x to the 1/2, I can do that. I just add 1, divide by, right? So 1/2 plus 1, 1/2 plus 2 over 2? 3 halves times? So I have my 2/3, I have my 3 halves. I'm finding it from 0 to 3. Ooh, I need to solve that definite integral, right?
Yes.
What am I really trying to find?
All that.
Oh, what do they mean?
See.
Same difference, right? Such a weird phrase. For my kiddos that hate fractional exponents, psh, I got you, because how can I rewrite to the 3 halves? Same dealio, right? I'm just solving. I plugged into my formula. I plugged into MVT for integrals. You guys just wrote down. I'm solving him to figure out what that number is. Number? Yep, number. I'm pulling the 2/3 out. He's just a constant, right? I can ignore him till later. I plug in 3. I get 3 root 3. Minus 0 root 0. Well, that's nice because 0 root 0 is just 0. 3 root 3. Well, 3's cancel with the 2/3. It's algebra right now, kiddos? Uh-oh, right? Algebra. Divide by 3. Divide by 3. Square root of c is equal to 2/3 root 3 squared c, or x star, or whatever you want to call. You can name him the special x. I don't know. 2 squared, 4, 3 squared, 9, root 3 squared, 3. 4/9 times 3. Dun 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 dun. What on earth did we just do? We were little robots and we plugged into a formula and we're at the end and whatever, we have the right answer, we don't care what it means. Partially, I know. But, hold on, wait. It'll be quick, I promise. What is it between 0 and 3?
Yeah.
Who's this? Yeah? What's this? Represented by? Right? That's not us. Wait a minute. What did we find at the end?
See.
C is what kind of value? And x. Well, what is so stinking special about 1 1/3? There exists a perfect rectangle such that at 4/3 going up to f of 4/3, this rectangle's area is the exact same area as the interval. Yep. That's what MVT for integration does. At 4/3, that rectangle, that geometric shape, is the exact same thing as the area of the curve square root of x between 0 and 3. Now, you won't have to stress, disclaimer, you won't have to stress too much about the graphical interpretation. It's kind of cool to see that there exists a perfect rectangle. Somewhere in that interval, there's one x such that his height with the base is the actual area, the exact area, but you won't use the graphical application too much. Okay. Cool kids. I want you to turn in your books to section 6.6. That's our last example? True. Homework help, real quick, just one. Then we're going on to 6.7. Motion with integrals. Exciting. You should get an FRQ packet tomorrow that we're going to start working on Wednesday. Yeah. Maybe tomorrow, most likely Wednesday. What else is Wednesday on the backboard?
It rhymes with forever quiz.
Forever
It
quiz.
rhymes with forever quiz. Mine are a little bit better than that. Forever quiz on Wednesday. You have a lot of them. They're super duper important, and they include basic integration rules. My ones who still don't have them memorized, I don't know who you are, but be memorizing. Homework 33 is due tomorrow, should have been due today, but I'm giving you a little bit of grace because of MVT for integration. Homework 34 is what we're doing tomorrow. We're finishing it quick for us. That's going to be due on Wednesday. AP number 10. That some of us are in serious denial as to ever having gotten. AP number 10 is due on Thursday. Why due on Thursday? Because we have an FRQ packet that we're getting Wednesday. Now, the nice thing is, we're working in class on the FRQ packet, and whatever we don't finish will be the homework. There is no more book work for this chapter after homework 34. But we will be working on the FRQ packet. It will be homework, it will be classwork, it will be just, we're going to barrel our way through it and hopefully get down a really good habit, a really good pattern of how to solve what the AP guys love to put on the test. Emily?
So FRQ package you're going to be doing Thursday too?
No, not Thursday. We'll see. Here, insight into teacher brain real quick. There's a 3-day weekend this weekend, so there's no way I can possibly expect you guys to hold on to anything that you've learned in calculus after those 3 days, right? So how are we going to take a test after those 3 days? We're going to fit in a test on Friday. That's going to be brutal torture, so we're going to figure it out. What I believe, based on my experience, which is more than you guys' as to what is best for you and your grades. Done. Okay, grades, updated, online, go check them out. If you have a spot check that's a 0, you should show it to me for half credit. My slackers, here we go. Paige, do I stare at people? I don't mean to. I'm scanning the room. I should just not look at anyone. Okay, we are in section 6. Can anybody find me the traffic flow one?
74.
You girls know what I mean. 70.
Yeah, it's 74. Wait.
4?
Yeah, 74.
Okay. Number 74. If anybody was working on this, you might have gotten a little stuck. It's called the traffic flow problem. Remember, we shorten things, right?
I did.
Some of us are working on it. We're growing. What do they? Are you there? Page what? 6? Oh, never mind. I don't know what I'm talking about. Sorry. What are you given in the problem? Rates. They give me R of t. Oh, stink. They can do that now? They can give me the rate? No. Yes, because I can go forward to the rate of the rate or backward to the change. We haven't really talked about it yet. Rate. What's my equation?
100 minus 1.
Is it 1 point?
100 times 1 minus 0.
How many zeros? 3?
3 zeros and then a 1. T squared.
Sorry, thanks guys. I have issues with hearing and then writing numbers. Okay, so, ironic. In part A, long story short, there's cars and it's traffic, right? It's rush hour-ish, between 4:30 and 5:30. I know, rough, right? Applies to real life. Cars per minute since 4:30, so t equals 0 at 4:30. And then if we're going to 5:30, and it's measured in minutes, t equals 60, so between 0 and 60. A, when does the peak traffic flow? I just want to help a few of you guys think through this so I don't have as many questions later. Peak. Peak. Mathematical word. Peak.
Maximum.
Maximum. Right? Peak, traffic flow, maximum, what else? Traffic flow. Traffic flow. Are they saying when are the most cars on the freeway? They're saying when
Busy.
is the traffic flow highest? What can I say measures traffic flow? Rate. The fastest cars or the maximum cars per minute getting on the freeway. Maximum rate. Wait, hold on. This is like my box, right? How do I find the maximum of anything? Starts with a C and ends with a idical. Critical numbers of what? I find critical numbers, Benji, by finding the derivative of who? I'm going to find the prime of the rates. Even I got mixed up on this one. I do it every year, I think. Rate prime. I want to find the maximum flow, the maximum rate. Therefore, rate prime equals 0 dne. If you need to set up a little sign chart, you're going between 0 and 60, and hopefully you have a critical number somewhere. And ideally, hopefully, your signs go from positive to negative to indicate a max. I'm not going any more or any further than that on A. B, what is the question? Here is the big one, the big idea. That 6-7 needs and the FRQ packet needs. B asks us for what? How? Many. Keep going. Cars. What? How many cars enter? Keep going.
The highway.
During 4:30 to 5:30? Is that what they're saying?
Yeah, the rush hour.
No, in LA rush hour is a little bit longer, but anyway, okay. We won't be too bitter where we live.
Great weather.
Yes. But sometimes I get tired of sun. So, coming back. Question. What is the one equation they gave us? What does this stand for? Cars per?
Minute.
How do I do a number of cars from cars per minute? Cars per minute is like my derivative. Cars per minute is like my velocity. How do I get just cars? Antiderivative. How do I do an antiderivative? Integral. I can go from cars per minute over a certain region from 0 to 60 of my R of t. And what am I going to get? I'm going to get my, how many cars? We'll call him n of t. And I could do n of 60. How many cars at 60 minus how many cars at 0? This tells me the change in cars, or how many cars enter. It doesn't tell me how many is on the freeway. I have to know like an initial number to start with. But it will tell me the change in. And that is the main application of integration. Given a rate, given a derivative, being able to go back and say, what is the change in? That's all possible from FTC. Anyway, cool kids, can you use your calculator on this one?
Oh.
Yeah.
Well, yes. I'd say yeah.
Do what you think you should do. I don't want
It doesn't say you can.
steer your consciences. Okay, so here we go. Section 6-7. It's a great intro to 6-7. We have 5 minutes.
Are we beating period one?
We are beating period 1
Yeah.
by 5 minutes.
We're better.
We should not be measuring ourselves to others, right?
We're preparing.
But seeing ourselves with the Lord. In a good way and in a challenging way. Motion! Cool kids, be amazing. Motion formulas. Tell me anything you remember. Go, this is a little dangerous.
C
Anything.
equals RT.
What?
C equals RT.
Dirt.
Okay, from a long time ago.
SFT.
Distance equals rate times time, and that's like an average rate, so we're going to erase him because he doesn't need calculus. Okay, what else?
F of B minus.
Come on, go
F
past
of A
8th grade.
over
What?
A minus, of B minus.
Ooh! F of B minus F of A all over B minus A. I'm using little f's because back then that's all little f stood for. Equals the average rate of whatever that thing is that you're subtracting. Average rate of. So for my ones that do V of B minus V of A, you're finding the average acceleration. What else? My 3 main concepts. I have position, I have velocity, and I have,
Acceleration.
and then randomly I have speed, and who's he?
Absolute velocity.
There's one. All right, well, we got something. So then velocity is equal to x prime. Acceleration is equal to x double prime, or v prime.
Good.
But back then, we only knew how to go which way. We could only go forwards. But now we can go.
Backwards? No.
So how does that work? Sideways, that's getting a little too
Or
intense.
two-dimensional.
Remember, like one-dimensional. Okay, anyway. So, Sorry, are we still ready?
Yeah.
Review. Just put forever cards and go find them. Okay, so motion formulas. Now we can go. Now hold on. Wait a minute. Look at the progression. Position, which can stand for number of cars. It can stand for number of gallons. It can stand for the number of feet. I'm using this loosely. Motion, things moving, changing. Position to its rate. And then from velocity to its rate, or the rate of the change of position. Anyway, integration, we say, no. We're better than that. We can go backwards. Given acceleration. Find velocity. Now, I'm keeping everything indefinite right now. There's no bounds. I'm not trying to find between this time and that time. I'm just trying to find the general antiderivative expression for it. To find velocity, I'm going to take the integral, right? Isn't this the antiderivative of A? The antiderivative of A of t, dt. Which, if I was doing something like a physics problem, I could say, hey, acceleration, we'll just say there's only gravity acting on an object. I could say is negative 9.8 meters per second squared. The nice thing is, guys, we're not going to be dealing with, let me make one quick change. We're not going to be dealing with a varying acceleration. We're going to be dealing with a constant acceleration. So instead of having to stress about A of t, we're just going to say he's going to be some constant. In this class, at this level, we're not going to be dealing with varying acceleration. We're just going to be dealing with free-falling objects. Like, the only acceleration is gravity. We're not dealing with wind or anything crazy like that. How do we solve it? Well, guys, what is the integral of any constant?
Constant x.
Constant times a variable, but wait, we're dealing with t's, time. Plus c. But the ironic thing about plus c, and I think we've actually already kind of peeked at this, is, wait a minute, c is going to be the same thing when t is 0? No.
Free food.
Attention all high school students. Valentine's Day rose sales will continue today. Yellow roses are $3 and red roses are $4. All profit goes toward the school project. And a reminder, today is the last day and we will be selling outside of Ms. Nobble's office. Thank you.
You're welcome.
I'm just going. You guys can just write. We'll talk about it tomorrow. Plus c is going to be the same thing as the initial velocity. When we go to position, we take another integral of velocity, which will be the integral of what we already found. And so position is going to end up equaling, wait, t squared, 1/2, a sub naught t squared plus v sub naught t plus physics people. There's a reason why you use this formula. I will see you tomorrow. No vectors in Calc 1. Little bit in Calc 2. But not bad. Cool kids, we'll talk about motion tomorrow. Great job of getting stuff down though. Tonight, finish homework 3 and study here forever.
Mr. Hardy's class.
Yeah.
I went down 17%. I went from 88.
Be here till 4. I have a meeting. Workshop. If you want to buy me very much. Sorry.
나 오늘 집에 51은 들어갔어. 7시 51분에.
Last weekend.
와, 나 한번 했어.
How? You fast.
I know in my class.
진짜 살인할 것 같아, 나.
Nick. Oh, still there, buddy.
Physics.
Nick, I learned this. It's
Count 2
terrible.
does a little bit of vectors. Count 3 does more.
Don't like 80 physics. I dropped 70%.
Oh yeah, no, I
3
would.
days.
I would never bend you.
Thank you.
I will here and take it now. If I pass,
I think that day I forgot to write down grades. I noticed it was missing, and I thought you would be talking.
Really?
Really? What?
Just take it.
Huh?
Just take it. Take it. Wow. Okay, Nick. Okay.
And you can also ask, like, I don't know, 10 or something. Are you heavy? Yes. Okay. are you?
Good, how are you?
Good. You can ask someone to choose.
This is Travis.
You
After
could
I
ask
take
people.
my
If they've already
EBT
finished
test, and
Or you
my
could ask them.
ELF test Saturday, I have to report
But
it
similar
tomorrow.
idea. Similar idea.
No,
They should know
that's
how,
just
you
in
know
the
what I mean?
CSU
They should
system,
know how to
and
do it.
they'll,
This is chapter 6,
Yes.
right?
So just take it on the contract.
Was that the-
Anywhere after that? Okay. Miss, do you have a question?
Oh, you know what? I already checked it. I just forgot to put in the check mark. It's still there telling me that it needs to be changed.
Thank you.
So I'll change it. Thank you.
Miss D,
Yeah, okay.
in the velocity, having a C, like what'd you do after that? Like, you
Plus
replaced-
C? Oh,
Yeah.
when time is 0. Bye, kiddo. When time is 0, V of 0 will equal A times 0, which goes away. So C is the same thing as velocity at 0, same thing as initial velocity.
Oh, okay.
And that's what you guys, I know, did in physics.
Okay.
Yeah. Same thing as initial velocity.
Okay. Thank
But
you.
we'll talk more about tomorrow. Today, we just got it down real quick.
Okay, thank you.
You're welcome.
I know I wrote down the 4 different stops. One is breakfast, one is like, you know, where they're trip that they're,
All night?
yeah,
Okay.
there were 4 different stops, right? Castle, whatever that is, miniature golf,
I
right?
sent it. Yeah, hold on. Nikki sent me oh no, it's an Apple document. I can't open it. There was Sky High. There was bowling. There was mini golf. Mount Asia or something similar to Mount Asia. And then
I just don't know the breakdown of the costs, right?
yeah, but
I
it
have
should
to ask
theoretically be in their PowerPointing thing.
So they should be able to show us, right?
Yeah.
Okay. All right, so I'll see you over there.
Yeah, I have a question. I'm glad that we've actually gotten to